June 15, 1944. The waters surrounding Saipan shimmer under the relentless Pacific sun, their surface broken only by the white wakes of the American invasion fleet stretching to the horizon. In the cockpit of his Mitsubishi A6M Zero, Lieutenant Commander Hiroshi Nishizawa adjusts his flight goggles and peers through the morning haze at the distant silhouettes of American carrier aircraft climbing toward his formation. The veteran pilot, credited with over 60 aerial victories, allows himself a moment of quiet confidence. These new American fighters approaching his squadron look bulkier than the nimble wildcats he had grown accustomed to outmaneuvering. Their wings appear thick and heavy, their fuselages swollen with what he assumes to be unnecessary equipment. To Nishizawa and his fellow aces, these aircraft represent everything they had been taught to despise about American military philosophy. Crude, over-engineered machines built by a nation that prioritized industrial excess over warrior spirit and tactical finesse. The morning air carries the salt tang of the ocean and the distant rumble of aircraft engines, but beneath these familiar sounds lies something new, a deeper, more powerful growl that seems to reverberate through the very atmosphere. The Japanese pilots exchange glances, their expressions mixing curiosity with the casual dismissiveness that had served them well in the early years of the Pacific War. They had learned to identify American aircraft by their distinctive engine notes, and this new sound suggests yet another attempt by their enemies to compensate for pilot inexperience with mechanical complexity. What they cannot yet comprehend is that they are witnessing the culmination of 3 years of American industrial innovation, tactical evolution, and hard-won combat experience, the operational debut of the Grumman F6F Hellcat, a machine specifically designed to hunt and destroy the very aircraft in which they now sit with such misplaced confidence. The story of this moment begins not in the Pacific Theater, but in the conference rooms and design studios of American aircraft manufacturers who had spent the early months of 1942 analyzing the wreckage of shot-down Zero fighters, studying captured Japanese tactical manuals, and interviewing surviving American pilots who had faced the Emperor's naval aviation in desperate aerial combat. The Zero had initially shocked American military planners with its extraordinary range, climb rate, and maneuverability, characteristics that had enabled Japanese pilots to achieve air superiority from Pearl Harbor to the Coral Sea. However, American engineers had also noted critical weaknesses in the Zero's design philosophy. Its emphasis on agility had come at the cost of pilot protection, structural durability, and firepower. The aircraft lacked armor plating around the cockpit, self-sealing fuel tanks, and the heavy armament necessary for decisive engagement outcomes. These design choices reflected not engineering limitations, but fundamental differences in military philosophy. Between the two nations, Japanese aircraft designers had prioritized the spiritual and tactical elements of aerial combat, the ability of a skilled pilot to outmaneuver his opponent through superior technique and warrior dedication. American engineers, drawing upon their nation's industrial capabilities and pragmatic military tradition, approached the problem from an entirely different perspective. They would create an aircraft that could absorb punishment while delivering devastating firepower, allowing American pilots to survive their mistakes while learning to exploit Japanese tactical predictability. The result would be a machine that embodied the American approach to warfare. Overwhelming technological superiority applied with methodical precision. The development of the F6F Hellcat had begun in earnest during the summer of 1942, as reports from the Battle of Midway revealed both the continued lethality of Japanese naval aviation and the growing effectiveness of improved American tactics. Grumman's design team, led by Chief Engineer William Schwendler, had studied every available piece of intelligence regarding Zero performance characteristics and Japanese pilot training methods. They learned that Japanese aviators were taught to enter combat with the assumption that their aircraft's superior agility would allow them to dictate the terms of engagement. Zero pilots typically sought to draw American fighters into turning dogfights where their lighter, more maneuverable aircraft could gain positional advantages through tight radius turns and rapid climb rates. The Hellcat's design philosophy directly countered these Japanese tactical assumptions. Rather than matching the Zero's agility, American engineers created an aircraft that could engage Japanese fighters on entirely different terms. The F-6F would be faster in level flight and diving attacks, more heavily armed with 650 caliber machine guns, and protected by comprehensive armor plating that would allow it to survive damage that would prove fatal to Japanese aircraft. Most importantly, the Hellcat would be powered by the Pratt Whitney R-2800 double wasp engine, a massive 18-cylinder radial that produced over 2,000 horsepower, nearly double the power output of the Zero's Nakajima Sakai engine. This engine represented more than mere mechanical superiority. It embodied the fundamental differences between American and Japanese industrial capabilities. The R-2800 required precision manufacturing techniques, advanced metallurgy, and quality control standards that stretched Japanese industrial capacity beyond its limits. American factories, drawing upon decades of automotive manufacturing experience and a virtually unlimited supply of strategic materials, could produce these complex engines with reliability standards that Japanese manufacturers found impossible to match. Each Hellcat engine contained more high-grade steel than an entire Japanese fighter aircraft, and American production lines would ultimately manufacture over 1,000 of these power plants during the war. Years, the symbolic weight of this disparity would not be lost on Japanese pilots who found themselves increasingly outmatched not merely by individual American aircraft, but by the industrial system that could produce such machines in seemingly endless quantities. Lieutenant Commander Nishizawa, preparing for combat on that June morning over Saipan, represented the pinnacle of Japanese pilot training and experience. He had learned to fly in an era when Japanese naval aviation was considered the finest in the world, when Zero fighters had swept Allied aircraft from Pacific skies with apparent ease. Yet, he was about to encounter the product of an American military-industrial complex that had absorbed the lessons of early defeat and transformed them into technological superiority through methods that Japanese strategic planners had fundamentally misunderstood. The first prototype F-6F had taken flight on June 26, 1942, exactly 2 years before this moment over Saipan. Test pilots had immediately recognized that Grumman had created something extraordinary, an aircraft that combined the eye-ida ruggedness of American industrial design with performance characteristics that could match or exceed any fighter in the world. The Hellcat could reach speeds of over 380 miles per hour in level flight, climb to 20,000 feet in less than 8 minutes, and maintain structural integrity under G-forces that would have torn apart lighter Japanese aircraft. More importantly, it could perform these feats while carrying 650 caliber machine guns, each loaded with 400 rounds of ammunition, a firepower concentration that could destroy enemy aircraft with brief, decisive bursts. American pilots training on the new fighter discovered that the Hellcat's design allowed them to employ tactics that had proven impossible in earlier aircraft. They could engage Japanese formations from high altitude, diving through enemy formations at speeds that Zero pilots could not match, deliver devastating gunfire attacks, and then climb away before Japanese fighters could respond effectively. This tactical approach, known as boom and zoom, eliminated the dogfighting scenarios where Japanese pilot training and aircraft agility provided decisive advantages. Instead, American pilots could engage their enemies at times and places of their own choosing, applying superior firepower and aircraft performance to achieve quick, conclusive victories. The psychological impact of this tactical revolution extended far beyond mere combat effectiveness. Japanese pilot training had emphasized the spiritual aspects of aerial warfare, the belief that superior dedication, training, and warrior spirit could overcome material disadvantages. Zero pilots had been taught that their aircraft's agility and their own tactical skill would allow them to defeat any opponent through pure flying ability. The Hellcat's design philosophy directly challenged these assumptions by creating combat scenarios where traditional Japanese advantages became irrelevant. American pilots could win engagements without entering the turning, fights where Japanese training provided its greatest benefits. This transformation in aerial combat reflected broader changes in the Pacific War's strategic dynamic. By 1944, American industrial production had reached levels that Japanese June 15, 1944. The waters surrounding Saipan shimmer under the relentless Pacific sun, their surface broken only by the white wakes of the American invasion fleet stretching to the horizon. The Hellcat production line at Grumman's Bethpage facility was delivering over 600 fighters per month, while Japanese aircraft manufacturers struggled to replace their losses with inferior aircraft flown by increasingly inexperienced pilots. The numerical disparity had become so pronounced that American task forces could afford to employ tactical methods that emphasized firepower and attrition over finesse and conservation. Lieutenant Commander Nishizawa, climbing toward the approaching American formation, embodied both the strengths and limitations of Japanese naval aviation at this critical juncture. His personal combat record represented the culmination of pre-war Japanese pilot training methods that had produced some of the most skilled aviators in aviation history. He had learned to fly with an intuitive understanding of his aircraft's capabilities, developing the split-second timing and spatial awareness necessary to outmaneuver opponents in close-quarters aerial combat. His Zero fighter, despite its structural limitations, remained one of the most agile aircraft ever built, capable of maneuvers that could surprise and overwhelm less experienced pilots. Yet neither Nishizawa's skill nor his aircraft's agility could address the fundamental, strategic reality that Japan faced in the summer of 1944. The Imperial Navy's pilot training programs, which had once produced aviators of extraordinary quality, had been devastated by nearly 3 years of continuous combat. The veteran pilots who had spearheaded Japan's early victories were dead, missing, or exhausted by repeated combat deployments. Their replacements, rushed through abbreviated training programs with limited fuel allocations for practice flights, lacked both the experience and proficiency necessary to exploit their aircraft's theoretical advantages. The Americans approaching Nishizawa's formation represented an entirely different pilot development philosophy. Rather than relying on a small cadre of elite aviators, American training programs had focused on producing large numbers of competent pilots who could employ superior equipment and standardized tactics to achieve consistent results. These American pilots had trained on aircraft with performance characteristics similar to those they would fly in combat, using unlimited fuel allocations that allowed them to develop genuine proficiency before facing enemy opposition. They had studied Japanese tactics through captured documents and debriefings with experienced pilots, learning to exploit known weaknesses in Zero design and Japanese tactical doctrine. The Hellcat pilots climbing toward the Japanese formation had been trained specifically to counter the tactical methods that had made Zero fighters so effective in earlier Pacific battles. They understood that Japanese pilots would attempt to draw them into turning dogfights, where Zero agility could provide decisive advantages. Instead, they had been instructed to maintain altitude and speed advantages, engaging Japanese formations through high-speed diving attacks that minimized exposure to enemy defensive fire while maximizing the effectiveness of their own heavier armament. This tactical approach, supported by comprehensive intelligence regarding Japanese aircraft limitations and pilot training methods, had already begun to produce devastating results in earlier engagements. The sound of approaching American engines grows louder, carrying with it the deep, powerful rhythm of R-2800 radials operating at combat power settings. To experienced Japanese pilots, this engine note represents something more threatening. than mere mechanical noise. It signifies the operational presence of an aircraft, specifically designed to destroy their fighters using methods that neutralize traditional Japanese tactical advantages. The Hellcat's engine produces not only superior power, but also superior reliability under combat conditions. American pilots could apply full military power settings for extended periods without risking engine failure, while Japanese engines required careful power management to avoid mechanical breakdown during critical combat phases. This reliability differential reflected fundamental disparities in manufacturing quality and strategic resource allocation between the two nations. American aircraft engines were built using high-grade alloys, precision manufacturing techniques, and quality control standards that ensured consistent performance under extreme operating conditions. Japanese engines, constructed with increasingly inferior materials as strategic resources became scarce, suffered from reduced reliability that forced pilots to exercise caution during the precise moments when maximum performance was most critical. A Japanese pilot engaging American fighters could not rely on his engine to deliver full power throughout an extended combat sequence, while his American opponent could operate at maximum performance settings with confidence that his power plant would continue functioning normally. The formation of Hellcats approaching Nishizawa's squadron represents more than individual aircraft. It embodies the systematic application of American industrial and technological capabilities to the problem of achieving air superiority over Japanese naval aviation. Each F6F carries approximately 2,400 rounds of 50 caliber ammunition, distributed among 6 wing-mounted machine guns that can deliver a combined rate of fire exceeding 4,800 rounds per minute. This firepower concentration, when applied accurately during brief engagement periods, can inflict catastrophic damage on enemy aircraft within seconds of initial contact. The devastating effectiveness of this armament had been demonstrated repeatedly in recent Pacific engagements, where single Hellcat pilots had achieved multiple victories during individual combat sorties. The psychological impact of facing such overwhelming firepower could not be underestimated. Japanese pilots had grown accustomed to aerial engagements where aircraft survived multiple hits from enemy weapons, allowing damaged fighters to continue maneuvering and potentially achieve favorable tactical positions despite battle damage. The Hellcat's concentrated 50 caliber armament changed these combat dynamics fundamentally by inflicting damage levels that eliminated enemy aircraft from combat within moments of initial contact. Japanese pilots, discovering that their aircraft could be destroyed by brief bursts of American gunfire, faced a tactical reality that undermined fundamental assumptions about aerial combat survivability. The WWII approaching American formation maintains strict flight discipline, with individual aircraft positioned to provide mutual support while maximizing collective firepower application during the impending engagement. This tactical formation reflects comprehensive study of Japanese combat methods and represents a systematic response to known Zero fighter capabilities. American pilots have been trained to avoid the individual dogfighting scenarios where Japanese pilot skill and aircraft agility provide decisive advantages. Instead, they employ coordinated tactics that allow multiple Hellcats to engage individual Japanese fighters simultaneously, overwhelming enemy defensive capabilities through superior numbers and firepower concentration. Lieutenant Commander Nishizawa adjusts his formation, signaling his pilots to prepare for combat while maintaining the tactical positioning that Japanese doctrine prescribed for engagements with American fighters. His squadron adopts the defensive formations that had proven effective against earlier American aircraft, with individual Zeros positioned to provide mutual support during the turning engagements that Japanese pilots preferred. These tactical preparations reflect years of combat experience and represent the application of proven methods that had achieved success against Wildcats, Corsairs, and other American fighters in previous Pacific battles. Yet the tactical assumptions underlying these Japanese formations had been developed through combat experience with American aircraft. that lacked the Hellcat's performance, characteristics, and firepower advantages. The F6F's superior speed and climb rate would allow American pilots to initiate and terminate engagements at will, engaging Japanese formations when conditions favored American success, while avoiding combat when Japanese positioning provided tactical advantages. This fundamental shift in engagement dynamics meant that traditional Japanese defensive formations would prove inadequate against an opponent capable of dictating the terms of aerial combat through superior aircraft performance. The moment of initial contact arrives with shocking suddenness. The leading Hellcats dive through the Japanese formation at speeds exceeding 400 miles per hour. Their 6 machine guns converging streams of 50 caliber fire on individual Zero fighters with devastating accuracy. The deep staccato bark of American weapons fills the air, punctuated by the explosive sounds of ammunition striking aircraft structures and fuel systems. Within seconds, 2 Japanese fighters have been transformed into falling masses of burning wreckage, their pilots killed instantly by the concentrated firepower that no amount of tactical skill could have avoided. Nishizawa witnesses the destruction of his wingman's aircraft with the detached professionalism that had enabled him to survive dozens of previous aerial engagements. But the speed and decisiveness of the American attack represents something entirely outside his combat experience. The Hellcat that destroyed his wingman had appeared, fired, and climbed away before any Japanese pilot could respond effectively. The American fighter's speed during its attack approach had made accurate defensive fire nearly impossible, while its rapid post-attack climb eliminated opportunities for Japanese counterattack. This tactical sequence demonstrated the fundamental obsolescence of Japanese defensive methods when applied against American aircraft with superior performance characteristics. The surviving Japanese pilots attempt to reform their defensive positions, but the Hellcats have already begun their second coordinated attack. American pilots maintain altitude and speed advantages that allow them to engage individual Japanese fighters while avoiding the turning dogfights where Zero agility could provide defensive benefits. Each American attack consists of a high-speed diving approach, brief but devastating gunfire application, and immediate climb back to altitude for subsequent attack positioning. This tactical method, repeated systematically throughout the engagement, eliminates Japanese fighters, one by one, while minimizing American exposure to defensive fire. The psychological impact of facing such systematically effective tactics proves as devastating as the physical destruction of Japanese aircraft. Nishizawa and his surviving pilots discover that their traditional tactical responses, tight turns, rapid climbs, coordinated defensive maneuvers, provide no effective counter to American methods that avoid close-quarters maneuvering combat entirely. The Americans engage Japanese fighters on terms that neutralize Zero advantages while maximizing the effectiveness of superior Hellcat performance and firepower. Japanese pilots, trained to achieve victory through superior flying skill and aircraft agility, find themselves facing opponents who have eliminated skill-based combat through systematic application of technological superiority. The engagement continues for less than 10 minutes, but in that brief period, the fundamental dynamics of Pacific aerial warfare undergo permanent transformation. Of the 12 Zero fighters that began the engagement, 8 have been shot down with devastating efficiency, their wreckage scattered across the ocean surface below. The surviving Japanese pilots, including Lieutenant Commander Nishizawa, discover that their aircraft have sustained battle damage that would have been considered minor in previous engagements, but now threatens their ability to return to base safely. The concentrated firepower of American .50 caliber weapons had inflicted structural damage that compromised aircraft control systems, engine cooling, and fuel system integrity. The 4 surviving Hellcats climb back to altitude, their aircraft unmarked by enemy fire and their ammunition supplies only partially expended. The American pilots report their victory through calm, professional radio communications that reflect the routine nature of what they have just accomplished. To these aviators, the destruction of experienced Japanese pilots and superior enemy aircraft represents successful application of proven tactics and equipment rather than extraordinary individual achievement. This psychological perspective, treating the defeat of Japan's finest pilots as a systematic, repeatable process, embodies the fundamental shift in Pacific air warfare that the F6F Hellcat had made possible. Lieutenant Commander Nishizawa, nursing his damaged Zero back toward base, experiences the profound psychological dislocation that accompanies the sudden obsolescence of hard-won expertise. His decades of flight training, his carefully developed tactical instincts, and his accumulated combat experience have proven inadequate against American methods that bypass traditional aerial combat entirely. The Americans had not outflown him. They had eliminated the conditions under which his flying skills could provide decisive advantages. This tactical revolution represented more than mere technological advancement. It signified a fundamental transformation in the nature of aerial warfare itself. The wreckage of Japanese aircraft, settling into Pacific waters, carries with it more than metal and human remains. It represents the destruction of strategic assumptions that had guided Japanese military planning throughout the Pacific War. The Zero fighters had embodied Japan's faith that superior training, tactical innovation, and warrior dedication could overcome material disadvantages through spiritual determination and technical excellence. The ease with which American pilots had destroyed these aircraft and their experienced pilots demonstrated the ultimate futility of such beliefs when, confronted with systematic technological and industrial superiority. American intelligence analysts, reviewing combat reports from this engagement and dozens of similar encounters throughout the summer of 1944, began to recognize patterns that would define the remainder of the Pacific War. The F6F Hellcat had achieved kill ratios against Japanese fighters that exceeded 19.1, meaning that for every American aircraft lost in aerial combat, Japanese forces were losing more than 19 fighters. This unprecedented exchange rate reflected not merely superior American equipment, but the systematic application of industrial capabilities, tactical innovation, and pilot training methods that Japanese forces could not match or counter effectively. The statistical reality of these combat results carried strategic implications that extended far beyond individual aerial engagements. Japanese naval aviation, which had begun the Pacific War with approximately 3,000 trained pilots, was being systematically destroyed at rates that made replacement impossible. The Imperial Navy's pilot training programs, already compromised by fuel shortages and experienced instructor casualties, could not produce aviators quickly enough to offset combat losses. Meanwhile, American training facilities were graduating over 1,000 new pilots per month, each trained to proficiency levels that Japanese abbreviated programs could no longer achieve. The industrial disparity supporting these personnel differences had become equally pronounced. American aircraft manufacturers were delivering over 2,000 military aircraft per month by mid-1944, while Japanese production had declined to fewer than 500 aircraft monthly due to strategic bombing, resource shortages, and manufacturing inefficiencies. The quality gap between American and Japanese aircraft had widened dramatically as Japanese manufacturers struggled to maintain production using inferior materials and increasingly inexperienced workers. Zero fighters rolling off production lines in 1944 lacked the build quality and performance characteristics of pre-war aircraft, while American fighters continued to improve through systematic engineering, refinement, and component upgrading. The symbolic significance of .50 caliber machine gun ammunition extends beyond its tactical effectiveness to represent fundamental differences between American and Japanese approaches to military logistics and industrial planning. Each Hellcat carried 2,400 rounds of carefully manufactured ammunition produced by American factories using quality control standards that ensured consistent ballistic performance and mechanical reliability. The copper, lead, and steel required for this ammunition came from American mines and smelters operating at full capacity, supported by transportation networks that could deliver raw materials and finished products with clockwork efficiency. Japanese ammunition production, constrained by resource shortages and declining manufacturing quality, could not match American standards for consistency or effectiveness. Japanese pilots frequently encountered ammunition failures during critical combat moments, misfires, inconsistent ballistics, and mechanical jams that could prove fatal during aerial engagements. These seemingly minor technical differences accumulated into tactical disadvantages that undermined Japanese pilot confidence and combat effectiveness. A Japanese pilot could not rely absolutely on his weapons functioning properly when most needed, while his American opponent fired ammunition that performed with machine-like consistency. The psychological burden of equipment unreliability extended throughout Japanese military organization, creating a cascading series of morale and effectiveness problems that American forces did not experience. Japanese pilots learned to conserve ammunition due to supply shortages, limiting their firing opportunities and reducing hit probabilities during combat. They flew aircraft with mechanical problems that American maintenance standards would have considered unacceptable, accepting equipment failures as inevitable rather than exceptional. They operated under fuel restrictions that limited training time and combat patrol duration, creating proficiency gaps that widened with each month of continuing warfare. American pilots faced none of these constraints. They trained with unlimited ammunition allowances, learning to fire with accuracy and confidence that came from extensive practice. They flew aircraft maintained to exacting standards by mechanics with access to unlimited spare parts and replacement components. They operated with fuel allocations that allowed extended combat patrols and training flights, developing proficiency levels that Japanese pilots could no longer achieve. These logistical advantages, multiplied across thousands of aircraft and aircrew, created systematic superiority that individual Japanese skill and dedication could not overcome. The sound of damaged Zero engines struggling to maintain power carries across the Pacific waters, marking the flight path of Lieutenant Commander Nishizawa and his surviving pilots as they attempt to reach the safety of their base. The irregular rhythm of failing Japanese engines contrasts sharply with the steady drone of departing American aircraft. There are R-2800 power plants operating with mechanical precision that reflects superior manufacturing quality and unlimited maintenance support. This auditory symbolism, the confident sound of American industrial might versus the uncertain stutter of Japanese mechanical desperation, captures the essential dynamic that would define the remainder of the Pacific. Ward Nishizawa's combat report, filed upon his return to base, would attempt to explain the tactical revolution he had witnessed in clinical, professional language that could not adequately convey the psychological impact of encountering systematic American superiority. His superiors, reading descriptions of American aircraft performance and tactical methods, would struggle to develop countermeasures for problems that transcended traditional military solutions. The F6F Hellcat represented more than an improved fighter aircraft. It embodied a systematic American approach to warfare that eliminated Japanese advantages through comprehensive technological and industrial superiority. Strategic implications of this engagement would ripple throughout Japanese military planning as intelligence analysts recognized that their forces faced opponents who could replace losses faster than Japanese forces could inflict them. American aircraft carriers, protected by fighter squadrons equipped with virtually invincible aircraft, could operate with impunity throughout the Pacific. Japanese bases, defended by increasingly obsolete fighters flown by inexperienced pilots, could not prevent American bombing attacks that systematically destroyed remaining Japanese air power. The mathematical certainty of eventual defeat became apparent to Japanese planners who understood the industrial realities underlying American tactical success. Yet the human dimension of this strategic transformation remained embodied in individual experiences like Lieutenant Commander Nishizawa's encounter with technological obsolescence. He represented thousands of Japanese military personnel who discovered that their hard-won expertise had become irrelevant overnight, not through any failure of dedication or skill, but through the systematic application of American industrial and technological capabilities to the problems of modern warfare. Their personal defeat reflected a broader Japanese failure to comprehend the scale and efficiency of American military-industrial organization. The wreckage of Zero, fighters scattered across the Pacific Ocean floor, serves as a lasting monument to the collision between two fundamentally different approaches to military power. Japanese aircraft design had emphasized spiritual and tactical elements, the belief that superior pilot training and warrior dedication could overcome material disadvantages through pure flying skill and tactical innovation. American aircraft design reflected industrial and systematic approaches, the conviction that superior technology, applied through standardized methods with overwhelming firepower, could achieve consistent victory regardless of individual pilot skill disparities. The F6F Hellcat's 19.1 kill ratio against Japanese fighters represented the systematic vindication of American military philosophy through combat results that could not be disputed or explained away. Japanese pilots, regardless of their individual skill levels or tactical innovation, could not overcome the fundamental performance advantages that American industrial might had built into their opponent's aircraft. The spiritual elements that Japanese military doctrine emphasized, dedication, sacrifice, warrior spirit, proved insufficient when confronted with systematic, technological superiority applied through methods that eliminated traditional combat dynamics. American pilots returning from these engagements carried with them the quiet confidence that comes from systematic success, achieved through superior equipment and proven tactics. They understood that their victories reflected not personal superiority over Japanese opponents, but the successful application of American industrial and technological capabilities to the problems of aerial warfare. This perspective, treating military success as the predictable result of systematic preparation rather than individual heroism, embodied a fundamental shift in military thinking that would influence American strategic planning for decades to come. The statistical record of Hellcat combat performance tells a story of systematic dominance that transcended individual engagements or tactical innovations. Over 12,000 F6F fighters would be produced during the war years, achieving a combined kill ratio of 19.1 against all Japanese aircraft types encountered in Pacific combat. This unprecedented success rate reflected not merely superior aircraft design, but the systematic application of American industrial capabilities, pilot training methods, and tactical doctrine to the problem of achieving air superiority over Japanese forces. The symbolic weight of these statistics extends beyond mere numbers to represent the fundamental transformation of warfare through industrial application. The Hellcat's success demonstrated that modern military conflicts would be decided not by individual skill or tactical innovation, but by systematic superiority in industrial production, technological development, and logistical organization. Japanese forces, despite their initial advantages in pilot training and tactical experience, could not overcome American systematic advantages once those capabilities had been fully mobilized and applied to Pacific warfare. The lesson embodied in Lieutenant Commander Nishizawa's encounter with American technological superiority would resonate throughout the remainder of the Pacific War and beyond. Military planners in every nation would study the Hellcat's systematic destruction of Japanese air power as a demonstration of how industrial capabilities could be transformed into decisive military advantages through proper application of technology, training, and tactical doctrine. The age of warfare dominated by individual skill and tactical innovation had ended, replaced by systematic approaches that emphasized technological superiority and industrial organization over traditional military virtues. The deep drone of American aircraft engines fading into Pacific distances carries with it the sound of fundamental change in the nature of military power itself. The F6F Hellcat had proven that systematic American advantages, industrial capacity, technological innovation, comprehensive training programs, and unlimited logistical support could be transformed into tactical dominance that individual enemy skill could not counter. This transformation represented more than victory in a specific military engagement. It signified the emergence of a new form of warfare where systematic superiority would prove more decisive than traditional military virtues like courage, skill, and tactical innovation. The Pacific waters, unmarked by the passage of aircraft overhead, continue their eternal rhythm while beneath their surface rest the remains of Japanese fighters and pilots who discovered too late that the nature of warfare itself had undergone permanent transformation. Their sacrifice, though militarily futile, represents the human cost of strategic miscalculation and the tragic consequences that follow when military organizations fail to adapt to technological and industrial realities. The F6F Hellcat's systematic destruction of Japanese air power stands as both testament to American industrial achievement and memorial to the individual courage of pilots who fought against impossible odds with obsolete equipment and inadequate support. In the end, the story of the Hellcat's dominance over Japanese aviation represents more than military history. It embodies the triumph of systematic organization over individual excellence, industrial capability over spiritual dedication, and technological innovation over traditional tactical methods. The aircraft that Japanese pilots had initially dismissed as crude and over-engineered proved to be the instrument of their systematic destruction, achieving through methodical application of superior technology what no amount of individual skill or warrior spirit could prevent. The 19-to-1 kill ratio stands as permanent testimony to the decisive power of American industrial and technological superiority, systematically applied through methods that transformed the very nature of aerial warfare itself.